here we want to calculate the final value of a deposit of $1,000, so that's our principal, invested at a rate of 2.8, so we need to change that to a decimal, so it's 0.028 per annum for 4 years. So this is my term is 4 with the following compounding periods. So this is where my n is going to come from, because remember we're talking about compounding interest, so the amount is equal to the principal times 1 plus the rate over the number of times it's compounded, all to the power of n times t, which is your term. So in A, semi-annually, that means n is equal to 2. Quarterly, n is equal to 4 because it's every quarter, 4 times a year. And monthly, well, there's 12 months in a year, so n is equal to 12. So let's see. Well, A is equal to, in this case, 1,000 times 1 plus the rate is 0.028. It's being compounded 2 times a year, and 2 times t, which is 4. And again, making sure that you know how to put this into your calculator, and if you're trying it and you're not getting the same answers I'm getting here, make sure you're talking to me to see if we get it. So 1,000 times 1 plus 0.028 divided by 2, close your bracket, all to the power of 2 times 4, which would be 8, and you get $4,112, and it's 784, so that's going to be 78 cents. So that's if it's compounded semi-annually. Now let's see if it's compounded 4 times a year, so quarterly. Everything is going to be the same except for this 2 and this 2 are now going to be 4s. So this is 1,000 times 1 plus 0.028 divided by 4, and this is 4 times 4. So that's going to be 16 up here. So 1,000 times 1 plus 0.028 divided by 4, all to the power of 16. And I definitely messed something up there, so I'm going to have to go back and change it. $1,118, and that's 8 cents. I think I forgot to use brackets up here and put in 2 times 4 instead of 8. So let's go back. We're going to change this answer. And it doesn't even make sense that after 4 years you would have $4,000. That would be amazing, but not realistic. So let's try that again. 1 plus 0.028 divided by 2, all to the power of 8. This is better. So this would be $1,117.64. That makes more sense. Okay, and then C, if it's compounded monthly, again, everything stays the same except for the n, so it's still 1,000 times 1 plus 0.028 divided by n is now 12, and this is 12 times 4. So this is going to be 48. So 1,000 times 1 plus 0.028 divided by 12, all to the power of 48. Now we've got $1,118.37. So you can see it's gone up a little bit each time. Bigger difference between semi-annually and quarterly than there was between quarterly and monthly. And in fact, it'll keep going up if you did it 365 days a year. So daily, it would go up more, but it wouldn't be a huge difference between the two. Let's look a little bit at what this formula even means. So here, what it's saying is you get this principal back plus your interest. So this is your interest. But each time they're calculating the interest, you're getting 2.8% per year. So you're not getting 2.8% per 6 months. So they divide it by 2 because that's how much interest they're going to add on. And then they're doing it 8 times over the course of 4 years. So that's kind of what this means. So you don't have to know what it means, but if you can kind of get that into your head, what is happening here mathematically, that'll help you a little bit. Again, you don't need to memorize the formulas. You can write them down on your reference guide, your study guide to bring to your quiz, and make sure you do. But you do need to understand what each one means, make sure you know what they are. So you can see again, as it's compounded more often, it goes up a little bit. And so compounding more often when you are getting the interest is a good thing.